by biology once life arose.
There may be life elsewhere than in the two small sites we examined, or perhaps there's life of a different sort all over Mars. Life is just a kind of chemistry of sufficient complexity to permit reproduction and evolution. I wonder if we'll ever find a specimen of life based not on organic molecules, but on something else, something more exotic.
The Viking experiments found that the Martian soil is not loaded with organic remains of once living creatures. Maybe the reactive chemistry of the surface has destroyed organic molecules based on carbon. Or maybe there's no life on Mars and all Viking found was a funny soil chemistry. Or maybe there's life, okay, but it's not based on organic chemistry as much as life is on Earth. Personally, I don't think that's a very likely possibility. I'm a carbon chauvinist. I freely admit it. Carbon is tremendously abundant in the cosmos, and it makes marvelously complex organic molecules that are terrifically good for life. I'm also a water chauvinist. It's an ideal solvent for organic molecules, and it stays liquid over a very wide range of temperatures. But sometimes I wonder, could my fondness for these materials have anything to do with the fact that I'm chiefly made up of them? Are we carbon and water based because these materials were abundant on the early Earth at the time of the origin of life? Might life elsewhere be based on different stuff? I'm a collection of organic molecules called Carl Sagan. You're a collection of almost identical molecules with a different collective label. But is that all? Is there nothing in here but molecules? Some people find that idea somehow demeaning to human dignity. But for myself, I find it elevating and exhilarating to discover that we live in a universe which permits the evolution of molecular machines as intricate and subtle as we. The essence of life is not so much the atoms and small molecules that go into us as the way, the ordering, the way those molecules are put together. Now, we sometimes read that the chemicals which make up a human body are worth, on the open market, only 97 cents or $10 or some number like that. And it's depressing to find our bodies valued at so little. But these estimates are for humans reduced to our simplest possible components. What is all this stuff in front of me? These are exactly the atoms that make up the human body, and in the right proportions, too. We're made mostly of water, and that costs almost nothing. The carbon is counted as coal. The calcium in our bones is chalk. The nitrogen in our proteins is liquid air. The iron in our blood is rusty nails, some phosphorus and some trace elements. If we didn't know better, we might be tempted to take all these atoms and mix them together in a container, like this. And stir. We could stir all we want, and at the end of it, all we'd have is some boring mixture of atoms. How could we have expected anything else? The beauty of a living thing is not the atoms that go into it, but the way those atoms are put together. Information distilled over 4 billion years of biological evolution. Incidentally, all the organisms on the Earth are made essentially of that stuff. An eyedropper full of that liquid could be used to make a caterpillar or a petunia, if only we knew how to put the components together.
All life on Earth is made from the same mixture of the same atoms. On another planet, the jars of life might be filled with very different atoms and small molecules, But I think the life forms on many worlds will consist, by and large, of the same atoms that are popular here, maybe even the same big molecules. So I don't believe we can rescue the idea of life on Mars by appealing to some exotic chemistry. Sometimes we hear about possible life forms in which silicon replaces carbon, or perhaps liquid ammonia replaces liquid water. But at Martian temperatures, there don't seem to be any plausible silicon-based molecules which might carry a genetic code. And ammonia is liquid only under higher pressures and lower temperatures. Someday in the distant future, we might have a collection of jars, each containing the elementary biochemistry of another world. I don't know if there'll be one labeled Mars, but if there is, I bet it will be full of organic molecules.
But there's another way to search for life on Mars, to seek out the discoveries and delights which that heterogeneous environment promises us. One of the things that a grasshopper can do, but Viking can't, is move. We landed in the dull places on Mars. For all the solid scientific findings and tantalizing hints which Viking provided, we know that there are an enormous number of places on the planet far more interesting. What we need is a roving vehicle with advanced experiments in biology and organic chemistry, able to land in the safe but dull places and wander to the interesting places.
This roving vehicle was developed by the Rensselaer Polytechnic Institute. It has a long list of dumb things it knows not to do. A Mars rover hasn't got time to ask whether it should attempt a steep slope. Radio waves traveling at the speed of light take about 20 minutes for the round trip to Earth. By the time it got an answer, it might be a heap of twisted metal at the bottom of a canyon. A rover has to think for itself. Imagine a rover with laser eyes like this one, but packed with sophisticated biological and chemical instruments, sampler arms, microscopes, and television cameras, wandering over the Martian landscape. It could drive to its own horizon every day, a distant feature it barely resolves at sunrise. It can be sniffing and tasting by nightfall. Billions of people could watch the unfolding adventure on their television sets as the rover explores the ancient river bottoms or cautiously approaches the enigmatic pyramids of Elysium. A new age of discovery would have begun. Most of the human species would witness the exploration of another world.
Only 80 years ago, we could come no closer to Mars than straining to see a tiny, shimmering image through a telescope in Arizona. Now, our instruments have actually touched down on the planet. Viking is a legacy of H.G. Wells and Percival Lowell, Robert Goddard. Science is a collaborative enterprise spanning the generations. When it permits us to see the far side of some new horizon, we remember those who prepared the way, seeing for them also.
On each lander, there is a microdot on which is written very small the names of 10,000 men and women responsible for Viking's splendid achievement. One of the names in this microdot belonged to a friend of mine, a remarkable microbiologist named Wolf Wischniak. He was the first person to build a machine to look for microbes on another world.
His friends called it the wolf trap. It contained a liquid nutrient to which Martian soil would be added, and any microbes that liked the food would grow in that nutrient medium and cloud it. The wolf trap was selected to go with Viking to Mars, but NASA is especially vulnerable to budget cuts, and the wolf trap was removed as an economy measure. It was a terrible blow to Wischniak. He'd worked 12 years on